Hello folks, how's it going? Mike coming back at you here with another video on discrete mathematics. In the previous video, we introduced another logical operator, the conditional operator, or the rightward pointing arrow, also known as the implication. If you have two statements P and Q, the conditional is read as if P then Q, or P implies Q. We talked about the truth values for the conditional, and we talked about its logical equivalent. In this video, we're going to do a few practice problems. We're going to look at a truth table for a logical form involving the conditional, and then we're going to see an example of two logical forms being logically equivalent, one of them including a conditional, and then we're going to look at one more problem where we have two logical forms, each containing a conditional where they are not logically equivalent. So first one here, just coming up with a truth table for a logical form that has a conditional inside of it. We are going to come up with the logic table for not P or R implies not Q. So, as usual, create your table, 3 columns kicking off P, Q, and R, because we have the 3 letters showing up there. We have a not P showing up in there, so we need a table, or we need a column, sorry, for not P. And then that not P is part of a disjunction. So we need the column for the disjunction, not P or R. We also have a not Q as the conclusion of our conditional. So we need a separate column for the not Q. And then we need a column for the entire logic form itself. Not P or R implies not Q. So we have our 8 possible combinations of truth values for P, Q, and R. First column, really straightforward to figure out what that is. You're just switching the truth value of P for that particular row. 4 F's followed by 4 T's if you go down. Now we have the column for the disjunction not P or R. So looking at these 2 columns here, take the disjunction of those 2 columns. As long as there's 1 T in that row, then your disjunction is true. So this is going to be true, false, true, false, and then true, 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 and true, going all the way down. Because in each of these last 4 rows here, there is at least 1 T. So there is our column for the disjunction not P or R. The column for not Q, pretty easy, pretty straightforward. You're just switching the truth values of your Q column. So T's become F's, F's become T's. So that penultimate column, that second to last column there, the one for not Q, goes FFTT, FFTT. And now we are doing the conditional for these 2 rows. Not P or R implies not Q. This first column here, these are your hypotheses, and then the second column here, the not Q, that's your conclusion. So you have to be very careful about the order in which you read the trues and falses, because the order does matter in some cases. So first row, we have a true implying a false. Thinking back to our previous video, in the conditional, if a true implies a false, then that is a false. We have, in the next row down, we have a false implying a false. That is true. Again, anytime your hypothesis is false, your conditional is going to be true. The conditional, as we said in the previous video, is said to be vacuously true. Next row, we have a true implying a true, which is a true. Next, we have a false implying a true, which is a true. Next row down, we have a true implying a false, which is a false. Then another true implying a false, which is a false. And then the last two rows, in both cases, we have a true implying a true, which is a true. So we've completed our logic table for this logic form. We have FTTT, FFTT in that final column. So there we go. This was our one sample that deals with how do we come up with the truth table for a logical form that includes a conditional. You should, all the other columns previous to the final column shouldn't be anything new. There really shouldn't have been anything that was like uncomfortable. All that stuff we had done from our previous videos. All right, next one, we have P implies Q, and then we have not P implies not Q. We're going to see if these two things are logically equivalent. Do we come up with the same truth values for these two columns for each possible combinations of truth values for P and Q? So pause the video here, take a couple minutes or so, and fill out this table on your own, and see on your own if these two things are logically equivalent or not. See if you come up with the same truth values in the final two columns there. So pause it now, and once you think you have it, press play, and we'll see if you are right. All right, so let's see if you came up with the appropriate conclusion to the question of, are these two things logically equivalent? First thing we have to do is come up with the truth values for not P and not Q. That's really straightforward. You're just switching the value that you had in that row for each of P and Q. So not P is FFTT, not Q is FTFT. P implies Q. We're looking at these two columns here. And again, we're paying attention to the order that the T's and the F's are listed in the conditional, because the order does matter. A true implying a true gives me a true. A true implying a false gives me a false. False implying a true gives me a true. And then a false implying a false gives me a true. So that puts us at this stage. And now we do the same kind of thing, except we're doing it with the middle two columns, not P and not Q. You do not P implies not Q, again, being careful with the order. So we have a false implying a false, which is a true. We have a false implying a true, which is a true. We have a true implying a false, which is a false. And then we have a true implying a true, which is a true. So we have our completed table. We look at these last two columns. And the question was, are these two things logically equivalent? Well, if they were logically equivalent, then these columns would be identical. However, as you can see, there are two rows where the truth values are not the same. So therefore, these two things are not equivalent. P implies Q, and not P implies not Q. These two quantities, these two logical forms, I should say, are not logical equivalents of each other. There is a special name for not P implies not Q relative to P implies Q. And you may have heard of the word before. You may not have. We will talk about what that is in the next video. So third and final sample here. In the previous video, we said that the conditional has a logical equivalent. The logical equivalent of P implies Q is not P or Q. So now we're just going to go through the truth table here to see that those things are indeed logically equivalent. And when I say we are going to go through the logic table, I mean pause the video here, try to go through this problem on your own. Try to fill in each of the entries in this truth table and try to find on your own that you do indeed come up with the same two columns here at the end. So again, pause the video now. Once you think you have it, press play and we'll see if you arrived at the desired conclusion. Okay, so let's see if you got there. The column for not P is really straightforward, just switching the truth values of the entries in the column P. So not P goes FFTT. Now we're taking the disjunction of not P or Q, as long as there's one true in that row of not P as well as Q, then your disjunction is true. So it's going to go true, false, true, true. So that puts us right there. Now we just need to fill in our last column, the column for the conditional P implies Q. And from the previous video, from problems we've already done in this video here, it's really easy to see that you are going to get the identically same column for P implies Q as you did for not P or Q. A true implying a true is true. True implying a false gives you a false. False implying a true gives you a true. And false implying a false gives you a true. So we see the two columns are identically the same. All truth values match up. Therefore, that's what tells us that, oh yeah, these things are logical equivalents of each other. So this was just a nice little short video, just getting us a little bit more practice with filling out truth tables, now with conditional statements or implications being involved in them. In our next video, we are going to continue on with the talk about conditional statements, as well as a few very important words that are heavily tied in to conditionals. And we're going to see how some of them relate to each other. If you have any questions or comments, be sure to drop them in the comment section below. Otherwise, until the next video, take it easy, guys.